punched that in at some point yesterday, whether or not it was in another class or what, but because we had this stored in, and that was nice to know, hey, this is in here already. We didn't necessarily store it in X, Y, or Z, but that was on our calculator, so it was best to just go ahead and finish off the math right then and there, so that if you had to use your calculator for another class, you had this all perfect. So we had our nice little cross multiplying set up, put it in here, get it in the calculator, should get 5,684.575 feet. The problem was, and they do this a lot on the MCAs and the ACTs, that transit that they had at the bottom, and the transit is a fancy surveying machine that they use to get the angles right. That was 5 feet tall. Well, this was just the mountain from the top of the transit to the top of the mountain. So we had to add that additional little 5 feet for that transit and get 5,689.575. So, do we need to go into any more depth? Did somebody punch this in and not get that? So I can redo it up here and we can talk about it together. Please grab out your standards yellow sheet because we need to pre-rate ourselves on this wonderful stuff from section 5 and 6. And that'll be the remaining 3 of these. So I understand and can use the law of cosines to solve triangles given side, angle, side, or side, side, side. So some of that, you're going to go, oh yeah, I remember side, angle, side, and side, side, side. But law of cosines will be brand new to you. I can find the area of triangles given side, angle, side, or side, side, side. And then I can apply the law of cosines to real world applications. So take a minute. Rate yourself on those and check them. See if you can rate some stuff after the lesson. After the homework. All right. As I always do, I was working through the notes last night, and I thought, this is going to be like a vacation. This is one of those sections where it's all formulas. You know, if you know how to work with formulas, then the rest of the math is not going to be hard at all. But it's based on which triangles can we use this for. When we were talking about law of sines, remember, we were limited there. It was angle, angle, side, angle, or side, side, angle, that ambiguous case that we had to spend a lot of time talking about. So this is for other situations. The law of cosines, I will be able to understand and use the law of cosines to solve triangles given side, angle, side, or side, side, side. So in the past, you know, it's one of those things where, oh, Cedar was starting talking about the objectives, and people are like, wow, 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 that's all they hear when I say those things. But this is big. We have to know which triangles we can use what for. So when we had 2 angles, we were talking about law of sines. Or if we had side, side, angle, law of sines. But law of cosines is specific for side, angle, side, or side, side, side. So that's really important. And then we're going to find out there are some shortcut formulas to finding the area of a triangle if you have the information for side, angle, side, or side, side, side. And then tomorrow we're going to apply the law of cosines to real world applications. So tomorrow will be the whole word problem piece. So right down here, we just jump right in and it says, here's the law of cosines. Let triangle ABC be any triangle with sides and angles labeled in the usual way. So that means we've got our capital letter for the angles, and straight across from them, opposite sides will be lowercase. Now, what I don't like that we need to put on here that's missing is this. You have to check for that first. You have to make sure you have that side angle side or side 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 situation, or you can't use this. If you don't, then you and say, well, do I have enough for lopsideds? Could I use that instead? And just keep looking for formulas that will work. And we had talked before about how you're going to get all the formulas on your green sheets that, where was it? It was the sum and difference formulas, and below you're going to get those. So these are formulas you're going to get. But you know what? You accidentally memorize them anyway. It didn't take very long in college to memorize these because these formulas are used depending on which angle you have. So cosine of A, that's going to involve the cosine of angle A. We're going to have angle A. We have to have angle B for this one, angle C for this one, or it's which one you're looking for. You know, that determines which formula. And then these are not tough formulas because they always start and end with the same letter. So if we have angle A, then that means we're going to have a little a squared on the other side. And everything in between is b's and c's. B squared plus c squared minus 2bc. If we have B, starts and ends with B, everything else in between is a's and c's. C in the end, C at the beginning, a's and b's for everything in between. So it's not hard to memorize these formulas, but you won't have to. You know, we're going to do them take the test. So down here it says side angle side. And I don't know, in the future I think I want to take that stuff off because I would like us to remember there is a half step to all of these problems. We have to figure out which formula can I use. So solving a triangle, let's just say we saw this problem, it did not tell us what was going on. We would need to look and say, this is a side length, this is an angle, and this is a side length. Well, that's that side angle side situation because an included angle is the angle that's right between those two sides. So this is side angle side, and that's going to mean that I can use the law of cosines. So we're going to solve a triangle ABC. That means find everything that's in it. Given that little a is 11, little b is 5, and then our angle C that they've given us is 20 degrees. So I have angle C. I'm even going to want to use the formula that has the cosine of C in it. So it has to start and end with C. Everything in between is going to be a's and b's. A squared plus b squared minus 2ab cosine of C. Or, like I said, you guys will have the formulas. Just pull the formulas out and take a peek. So, I should just start putting stuff in. I mean, I've got the A and the B, and I have C. Let's see what we get. So C squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20 degrees. Really? That's all calculated. It is. So we're going to punch that in, see what we get, and that will give us C squared. And then from there, we'll just take the square root. So we just have to punch it in carefully. Oh, those that have my yellow calculator. So Cam and Jack, make sure it's in degree mode because my other classes might not be using degree mode right now. Everybody else, unless you change batteries, it should stay in degree mode. So 11 squared plus 5 squared minus, and then I usually use parentheses for everything that's being subtracted here. So 2 times 11 times 5 times the cosine of 20 degrees. You wouldn't have to do any of that math in your noggin if you didn't want to. And we get that. Now normally we wouldn't write down a little step like this because this is not our answer yet. But usually we want to see that you understand, yes, I'm going to punch all that in, I'm going to get something, but then I still need to take the square root. And with square roots, in this case, we're not going to worry about positive or negative because we're talking about the side length of the triangle. It's always going to come out positive. So second square root, second answer, 6.529, blah, blah, blah. Tell me the damn letters. So there it is, 6.529, blah, blah, blah. So now, I wonder if I should store that. I'm going to need that in the future. So I think about what I have left to find. I've got all 3 side lengths now. Here, here, and here, and I have one angle. So I'm going to need the other 2 angles. So do the formulas that have cosine B and cosine A in them, are they going to require that we use C? Then we better store it. And this time, because it's C, I'm going to go ahead and store it under C in my calculator. So I want to have that exact. So store alpha, and then C is the program button. Now that's in there and it's ready whenever I need to call up that side for C. Because the other two things I need are angle A and angle B. Might as well go in alphabetical order and figure out what A is first. So that formula is going to have cosine of A at the end. It's going to have A squared at the beginning. And then it's going to use B's and C's. B squared plus C squared minus 2BC. Now I'm not going to use it like that. Because this formula is built, these were called literal equations, to find side A. I already have side A. It's not side A I'm looking for angle A. So it's easier to do all of the rebuilding of the formula right now than it is once all the numbers are in there. Granted, with this one, they're giving us really nice side lengths, but sometimes they're not nice. So I realize what I really want is this capital A. So I'm going to have to subtract B squared and C squared, and then I'm going to have to divide by negative 2BC to get me the cosine of A. Wait a minute, I don't want the cosine of A. I want to know what the measure of angle A is. So what do I do with that to get the measure of angle A? Inverse cosine. So I'm going to go ahead and change this right now. Measure of angle A, inverse cosine of all of that. And then I'll put the numbers in. You know, it's very rare that somebody's going to make a mistake right here, rebooting this formula. So now we'll go put stuff in. So we need the inverse cosine, A squared, so 11 squared, minus B squared, which is 5 squared, minus, and here's where we're going to have to use our stored numbers, 6.529 squared, all over negative 2 times our B value of 5 and our C value of 6.529. So we're actually going to need to pull that stored information out twice to do this. And again, best recommendation is to always use a set of parentheses for the numerator and the denominator. Sometimes you don't need them, sometimes you do. It's just really safe to do that. So we need second cosine, so we can get inverse cosine up there, and parentheses 11 squared minus 5 squared minus, and now we have to recall our C value. So that's going to be second store alpha program, enter. So it pops up all my scores there. Squared parentheses. Now that's the top of my fraction. So now I need divided by another set of parentheses. Negative 2 times 5 times, and I have to recall the C again. So second store recall alpha program, enter, parentheses, and then one more set of parentheses to tell it I want the inverse cosine of this whole ball of wax. There it is. So 144.817 degrees. Okay. So now I need to stop and think whether or not I should store that. We've got little c, so all three sides were found. They gave us one of the angles. We just found another one. Can we get it without having to store that? Yeah, because we can just pull it up as our answer from the past. It wouldn't hurt to store it, but it's a little more than you need to do. So we still need the measure of angle B. So 180 degrees minus the 20 that they gave us minus the 144.817 that we just found. What we're going to use from our calculator so that we don't have it around here. So 180 minus 20 is 160 minus the answer we just got. 15.183 degrees. There it is. Now we take inventory. Yesterday I never had time to stop and put the whole inventory down, but we should do that every time we have one of these problems. Measure angle A, measure angle B, measure angle C, A, B, and C. So our measure of angle A was 144.817 degrees. Measure of angle B, 15.183 degrees. Measure of angle C was given to us, that was 20 degrees. Little a, 11. Little b, 5. I need a break in here. Comma would be helpful. And little c, we found that one up here, 6.529. Now, nobody stopped me this hour. First hour stopped me, right here, and said, hang on a sec. Wouldn't that give us side-side angle then? Couldn't we go ahead and just go back to what we know from the law of sines? And wouldn't we get the same answer? Yes and no. There's a problem. You know, we get so attached to these things because they know all kinds of stuff. I mean, they can practically do a little laundry for us. There's so much stuff they can do. There's certain things they're not so good at. I'm going to give you a for instance. Here's what I need you to do for me. I need you to punch in the sine of 40 degrees and the sine of 140 degrees. Let's see what your calculator comes. What do you notice about those answers? They're the same. That's because the calculator cannot distinguish between which two of those angles you need. It's going to say the same thing for sine of 40 degrees as it does for the sine of 140 degrees. But now let's check out cosine. What if you put cosine of 40 degrees and cosine of 140 degrees in there? You get exactly the same thing. So that's why we use cosine. And we just keep going with the same formula we've been using because it's the safe way to go. And that's what this little paragraph down here at the bottom mentions. Like it says, we could now use either the law of cosines or the law of sines to find one of those two unknown angles. But the best way, the safest way, is to stick with the law of cosines. So as a general rule, it's better to use the law of cosines to find angles, since that arc cosine, which is inverse cosine function, does know the difference. So the calculator knows the difference between a 40-degree angle and a 140-degree angle for cosine, but it doesn't know the difference for sine. So that's why we would use that. Any angle and its supplement have the same sine value, and the calculator can't tell us which one it is that we need. So we'll just stick with, hey, we started with the law of cosines, let's just keep using it. You know, it's the safe way to go with side angle side and side side side. So let's look at this one. Solving a triangle, the first thing we do is come over here and say, well, what did they give us? Ah, side, side, side. Okay, use law of sines because that's for angle, angle, side, angle, side, angle, and side, side, angle. But I can use the law of cosines because that's built for this. It's built for side, angle, side, and side, side, side. All right, I don't have any of the angles. Huh. Well, might as well go alphabetically. Go after A first. So ends with A, starts with A, B's and C's in between. So little a squared equals little b squared plus little c squared minus 2bc cosine capital. All right, so let's see. I've got to find the angles. I better rebuild this formula. So let's move everything over, and knowing we're going to have to do inverse cosine, we'll have a squared minus b squared minus c squared divided by negative 2bc. inverse cosine of that. That will get us the measure. So we're just manipulating the point. Again, in Algebra 2, that was called literal. So now let's put the numbers in and see what we get. So inverse cosine of 9 squared minus 7 squared minus 5 squared over negative 2 times 7 times 5. And then we'll just carefully punch that in. We get the measure of angle A. So I've got an extra set of parentheses just in case to make sure that the calculator takes everything in the numerator and divides it by everything in the denominator. Would be good. There it is. 95.739 degrees. So we stop and think. Are we probably going to need that later? Thank you. Big pile of stuff. Thank you. Thank you also. Have a great day, everybody. Thank you. All right, we've got the measure of angle A. How many more angles do we have to go? Yeah, we're going to have to store it. We're going to want it somewhere. And it's A. Hey, let's use A this time. So we will do store, and we need alpha, and the capital A is on math. There we go. So I'll just leave myself a little note here that we did use A this time instead of X, Y, and Z. And we'll keep going. All right. We need another one. Might as well stick with the old alphabetical and go after B. So we'll have cosine of B here at the end. We'll start with B squared. Then we'll have A's and C's in between, like so. What should we do with that? Oh, I see. You were already working, and then I had to stop and get the papers from them. So you already got this solved. All right. That's a good thing. It means you're really comfortable with it. I'll take it. See if we all end up with the same thing, huh? .704. Store that one, or can we just use the answer to generate what would be a P now? Are you storing it or not? Again, you can, we've already got it up there. So every triangle is 180 degrees. Doesn't matter if it's a right triangle or what. So we'll have 180 degrees minus 95.739 degrees minus 50.704 degrees. And that'll give us the measure of angle C. So if I just take 180 minus the answer I just had, minus second recall, alpha A, enter. We've got it. 33.557 degrees. I don't have any room to take inventory, but that's okay because with this one, we knew we needed all three angles, and we can see we've got measure of angle A, measure of angle B, measure of angle C, and all that. So check for that side, 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 side angle, side, and then you'll know. Just stick with the law of cosines as you go through it. So 43210, me. How you feeling about law of cosines? usually, if anybody has trouble, it's just because they punch something in a little wrong. Oh, good. Because those are the two examples we're going to do with that. I mean, it's not like what we had to do with law of sines where there were so many different situations that we can use it. We've got side angle, side, and we're done. So now we're going to talk about another part of your objectives, which is finding the area of a triangle without having to do the whole area equals 1/2 base times height, like we did back in geometry. Area equals 1/2 base times height is great. Don't get me wrong, it's fabulous. And at the geometry level, it's the best thing that you could be taught. And that's because they can safely say this will work for every single triangle. Area equals 1/2 base times height. The problem is, sometimes you have to do a whole lot of work to figure out what the height is first before you can use area equals 1/2 base times height. So there are a couple of really special situations that have specialty formulas. And the same parts that determine a triangle also determine its area. So if the parts happen to be two sides and an included angle, which would be side angle side, we get a simple area formula in terms of those three parts that does not require finding the altitude, the height. So I know this is called the area of a triangle, but that's really bad for them to put that up there. We should absolutely put side angle side, because that's the situation you have to use this area formula. And what it says is, if you need the area of a triangle, you've got two sides and the included angle. So we've got a side, another side, and we know the angle that's right at that point. All you have to do is take 1/2 times each of the sides times the sine of that angle. That's all you have to do. 1/2 BC sine of A. Now, the letters are there to tell us you have to have a side, the included angle, and then the other side. And that's how this A, B, and C stuff all fits together. And that's why there are two more of these formulas, because depending on which angle you get, you're going to have to set that up a little bit differently. And in example 3, we're not just going to find the area of a triangle. We're going to go after something we did in geometry that took a whole lot of math. And that's, we're going to find the area of a regular octagon. So this says find the area of the regular octagon. Octagons have 8 equal sides, 8 equal angles for regular octagons. And it's inscribed inside a circle of radius 9 inches. Okay, so way back in geometry, you had to use the formula area equals 1/2 apothegm times perimeter to figure out what the area of this was going to be. Again, that's a formula that worked for any regular polygon. But we could do it easier when we want to, and we can. Because if we know the radius is 9 for both of these, all we have to do is figure out what this angle is, and then we're going to be able to use this formula to find the area of this triangle. And there's 8 of them just like it, because it's an octagon. So that'll go a lot faster. But I need to know what that angle is. Start thinking. So if I start here on the octagon and I go all the way around, how many degrees have I gone? All the way around something, how many degrees? 360. There are going to be 8 congruent triangles in there. So if I just take 360 and divide it into 8 equal pieces, I'll know what that little angle is. What is it? It is 45 degrees. Well, this is going to be super easy, because this little formula we just had up there says all we have to do, and we're going to put triangle, capital A for area, so that this is a little bit different. Yeah, we have to have some symbolism that says this is a little different formula than one we've used in the past. So 1/2 side times the sine of the little angle that's in between. Well, that's how calculator work right there. 1/2 of 81 times the sine of 45 degrees. Cool. Practically don't need a brain for that. You can just punch away. 0.5 times 81 times the sine of 45. There it is. There's one of our triangles. So the triangle area, 28.638 with rounding. But how many of those triangles we're going to fit in here? So we better take times 8. So we don't need to store it. It's already in there. It's stored as the last thing we have. So we'll just take that times times 8, and there it is. 229.103. We do need to label this. And I look at it and realize, well, they had this in inches, so our little triangles were 28.638 square inches, but the area of our regular octagon is going to be 229.103 square inches. So why don't they teach you that in geometry? Because in geometry, we're trying to give you formulas that will work for everything. It's like you can cover a right triangle trig in geometry because all the formulas that we have for right triangles work for every right triangle. This is specialty stuff, so you have to know what to look for to see if you can use it or not. This, in fact, is one of the formulas that on the MCAs or the ACTs, if you remember this one, it saves you like 3 minutes on the test from trying to find the altitude. So if you notice it's a side angle side situation, this problem is, boom, you punch it in the calculator and you're done. Whereas this person next to you, if they don't know this formula, has to figure out, drop down the height, use sine, SOHCAHTOA to figure it out and go from there. So it's a big time saver if you can remember that formula. So area of a triangle. If that's in the homework, how are you going to do? 4, 3, 2, 1, 0. Everybody sitting with this one. Looks pretty good. All right. So we've got another one. Another specialty area formula. And that's Heron's formula. Heron's formula was built because he's working with triangles a lot and he's thinking to himself, can't I find an easier formula for the area of a triangle if I have all 3 sides? Isn't there just a way to use the 3 sides to figure out what the area of the triangle is? And he did, but it gets a little weird because there's a specialty piece here. So this is the one we use for side, 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 right here. Heron's formula. And A, B, and C are the triangle's side lengths. And it says, let S denote the semi-perimeter. Now that's where I said things get a little weird. Because we don't use the semi-perimeter for a lot of stuff. This is one of the few specialty formulas that this is used for. But semi means 2. So we're going to take the perimeter and we're going to divide it by 2. That's the semi-perimeter. So in this case it says, hey, if you know that, if you can add all 3 sides up, divide it by 2, then the area of the triangle will be the square root of the semi-perimeter times the difference between the semi-perimeter and each of the 3 sides. How far are they away from each other? And that'll work. That'll give you the area. So example 4 says we're going to use Heron's formula, which it shouldn't have said that because we want to be able to know we need that. But I look at this and I see they've given me side, side, side. That is Heron's formula. So notice the S's. We need to find another S. We need the semi-perimeter. So we're going to need to know what 13 plus 15 plus 18 divided by 2 is in order to do this easily with Heron's formula. So go ahead and calculate that. What are you getting for your semi-perimeter? 23. And then we grab Heron's formula, find the area, and we need the semi-perimeter, and then we have to look at each of the side lengths and see how far away from that semi-perimeter they are. So how far from 23 is 13? 10. How far from 23 is 15? 8 units. How far away for 18? 5. Calculator problem. It's a calculator problem. So you look under there and hopefully you're saying, okay, so if I just take 230 times 40, I'll have what I need for underneath the radical. And that's going to be the square root of 9,200. And then I just need the square root of that answer. That's it. So 95.917. Square units. They didn't tell us a label. We do have to put square units on this because this label is going to let somebody know that we are talking about area here. Let me put square on there. So 95.917 square units. Heron's formula. If that's in the homework on the test, 4, 3, 3210. All you gotta do. Good. I was hoping for lots of confidence with these formulas. Good, good, good. Because they're very specialized formulas. You just have to know when to use them. So here's what I need from you. Listen carefully so that you don't get tricked into answering something that you didn't want to answer. When should we use the law of sines? Somebody give me one. When do we use law of sines? Okay, is that you? Side, side, angle. Yep. Another one. Michael, give me another one. Angle, angle, side. Elena, give me another one. We have side, 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 angle, angle, side. Did that one. Did I say it backwards? Side, side, angle, 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 side, and that's the new one for cosine. SSA? AAS? Got that one. Angle, side, angle. So side, side, angle, 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 side, and angle, side, angle. Okay, now, law of cosines. Side, side, side. Side, angle, side. Okay. 1/2 BC sine of A for area. When can we use that? Side, angle, side. You have to have the included angle. When can we use Heron's? What do we have to have? Side, side, side. So notice it's a big deal. You have to know which ones can be used for what. Then the formulas, basic algebra, put the numbers in and see what you get. So that's, we're not going to finish there. Grab the white worksheet. So I think we have time for at least one review problem here, and then you'll still have some time left. PLC schedule. Yep. Let's do another review problem. We got a test coming up next Tuesday. Let's go to number 7. And let's see what you remember from a couple of days ago when we were solving. We're going to solve cosine squared x over 2 equals cosine squared x on the interval from 0 to 2 pi. So one rotation. And yes, some of you already grabbed your green sheet. That's exactly what you want to do. Okay. Solve. What do we have to have on one side of this equation to solve? A 0. But we also want it to be factorable. And that x over 2 thing, that's going to keep us from having this factorable. So I stop and think for a second. There must be something I could put in here that when I square it won't come out too cranky. Otherwise, they wouldn't have given me this. So take a look on your sheet and see if you can find something that would be relatively good to square that we have for cosine squared u over 2 on your sheet. Do you see it? Kind of a monster. Plus or minus square root of 1 plus cosine x over 2. Kind of a monster. Is that plus or minus going to matter if you square this? It's going to be positive no matter what, right? And then squaring a square root is going to cancel out. Oh, this just got much nicer right away. 1 plus cosine of x over 2 equals cosine squared x. We didn't have any fractions when we were factoring before. How can we get rid of that too? Multiply both sides by 2. And it'll look a little nicer. Alright, so we are going to have 1 plus cosine of x equals 2 cosine, I should put some parentheses there, cosine squared x. Okay, So to solve, you said we have to have a 0 on one side. Oh, I'd like to keep this one positive since that's my squared. So I'll move these over. This before. If you're uncomfortable factoring with cosine in there, make cosine x equal to y or something, and do it that way first. But I think most of you are able now to just go ahead and jump in and put 2 cosine x and cosine x there. So the important part of this is, where does the plus 1 go and where does the minus 1 go to get us the right middle term? Which one should go in the first parenthesis? Plus 1. Negative 2 cosine x plus 1 cosine x. That'll give us a negative 1 cosine x. So now comes the thinking part. And we go ahead and solve for cosine x. So we'd have cosine x equals negative 1/2. And cosine x equals 1. The easy one or the hard one first? Not that it's hard. Okay, so let's go after easy first. Where is the cosine of x equal to 1? That's 0. Now, the reason this one is harder for most people is because it's a cosine. We love sine. Opposite, we can tell right away where it is. Cosine is adjacent, and so that takes an extra little step in thinking. So cosine, oh, it has to be negative. Well, that's not going here. Could go here. Could go here. Can't go there. So we're talking about second and fourth quadrant. Let's see. There's my little reference triangle. Adjacent, hypotenuse, in degrees. What's that reference angle that we need right there? 60 degrees. What's that in millions? Pi over 3. So if this little chunk right here, this theta is pi over 3, give me the correct name for that angle. 2 pi over 3. Now swing it down into the third quadrant. What would its new name be? 4 pi over 3. All right. So one more review type problem out of the way. First hour I was going to try and go through number 11 with them, but that one's just going to take too long. So we'll save that for a review day here. So let me get you the assignment on the stuff you were saying. It's pretty good. Lots of good numbers for 561. Just the top one. The bottom one is the word problem stuff, and we'll do that tomorrow. And just like we saw with law of signs, that really the biggest struggle with word problems with you is just getting